Hi, everybody. Welcome to class. I'm David Whitlock. I teach the course, and I'm really excited to be back at PSU. I haven't taught since last winter, and I've missed it. I've missed interacting with the students. I've missed exploring these topics related to programming. With you all. And I'm super excited and proud and pleased that I've been invited back and to teach what is a lot of new content for the course. And actually, the name of the course is new. As we'll talk about, a lot of this stuff has been well vetted. Hello. Okay. So, well, anyway, hi everybody, and we'll run through some intro slides, and then we'll dive into the real guts of tonight. So, lots of stuff to do tonight, and I think we all saw that the class is scheduled to go from 5:30 to 9:10. I think tonight will probably be closer to 9. It'll be a long night. We'll make sure to take a couple of breaks to make sure that we're all well paced and can retain our focus. But we got a lot of stuff to cover tonight, and I'll be saying a lot of words. So I'm going to introduce myself to all of you, and I'd like each of you to introduce yourself to me and to everybody else. I'm really curious about who's here tonight, and what your experience has been, and what you're hoping to get out of the course. We're going to do a lot of typical first night stuff, like talking about the syllabus and the assignments, and the important things that you all need to know about how to navigate the course and get out of it what you're looking for. I'm offering this as a hybrid course, which I think is the first time I've done it. I think I've done, back when we had the attend anywhere option, I chose that one. I don't have that anymore, so I thought hybrid would be a good choice for this course. But I'm really curious to hear about your experiences, like in the last year or so, now that we have the option to be back on campus, about what kind of learning works best for you. And so we'll be talking a little bit about that also tonight. And then we're going to start doing some code. This course is all about coding. So we're going to learn how to create our first Java project, get started with that. We got a couple of assignments that are being handed out tonight, including one called the Java Koans. I'm not actually handing them out to you, but they're available online. And then, time permitting, we'll start talking about test-driven development and start to see how you do that in the Java project. That's a lot. It's pretty ambitious. Don't know if we're going to be able to get through all of it tonight and retain what little sanity we have left at the end of a day in the middle of a week when it's very dark outside. But we're going to try. Okay. Hey, all about me. Again, my name is David Whitlock. I've taught at PSU for quite a while now. I've had a lot of students come through, and it's nice. I've been doing this long enough that I've seen, I've got to know my students as professionals. I've worked with people who've taken my class before, and it's always nice to, catch up with somebody. We sometimes run into them on the street, or we'll see each other professionally in some context or whatever, and just hear about the experience that they've had after they've graduated. Oh yeah, thanks for posting the location of the room of the course. I'm an adjunct lecturer here, and so then during the day I manage software developers at a company called Tripwire that was founded here in Portland. And also I stay involved with the computer science department. If any of you are familiar with the PSEP internship program, I served on the steering committee for that for many, many years, almost since the beginning. And I recently left it because Tripwire is no longer part of it, but it's been really a great way to meet people who aren't my students, but who are also, but instead are part of the PSU community, and to watch them grow as software professionals. It's really awesome. And so then I just want to say that I'm just really excited to be here, and I look forward to learning about contemporary software development with all of you, and how we can bring joy and flow to our coding. I've been writing software for a long time. Most days I enjoy it a lot. And I was thinking about it, I was like, well, there's some reasons I enjoy it, and there's some things I like, some things that I don't, and I'm hoping to share a lot of that with you over the coming weeks. So I want to spend a couple slides talking about the class, and then we'll have an opportunity to meet each other. So it might be cliche, but the world runs on software, right? We use software every day, almost all the time. And software is written by people, right? We in our profession, we write software. It's what we do. We deliver solutions to problems via software. And software is comparatively a young profession, right? There aren't too many software engineers. Well, there have only been software engineers since like the 1940s, and even that's stretching it a little bit. So when you think about software, professional software development, we're really only a couple of generations into it. And when you think about, bridge builders or people who build roads, right? They've been doing that for, thousands of years. This is still pretty new. And so we're in this really exciting time where there's so many things to learn, so many things to try, some things you try and they don't work out. But we are all dedicated towards doing what we do more effectively to deliver better results to the people whose problems that we solve. And so then to sort of frame the course, there are 4 points that I'd like you to consider. So the first one is about software quality, and that high quality software provides a great experience for the people that use it, right? It does what they expect, and it does it in a way that makes sense to them and that they can accomplish what they need to accomplish quickly and with little toil. Also, for this course, it's important to understand that people work together to write software. And each one of you is learning as individuals, and certainly as your students in your academic career, you are working and assessed mainly on your own work, which is appropriate. It understands what we do, but that's not what you'll be doing very shortly if you choose to professionally write software. And so I want to give you an opportunity to experience that in the course. We'll talk about how we do that. Something that I've learned in my career is that I have spent far more time working with other people's code than working with code that I wrote myself. And there are skills to develop here, and there are techniques that you can apply to do this effectively, because this can be very difficult, right? When you're looking at a huge code base and you don't know where to get started, it can not only feel really bad, but it can then lead to ineffective behaviors and results. And then finally, software must evolve to meet new needs and demands. This isn't one and done. Again, I think a lot of the academic experience, I know mine was, where it's like, great, I wrote a program and I got an A and that was it. I never touched it again. Well, that's not what you do in the real world. You're continually working with your software, with other people's software to evolve it, to have it do better things. And I'd like you to experience what that's like in this course. Hey, welcome. So I want to dive into each one of those bullets a little bit more and sort of, again, give you additional framing for the course. And so the first one is being able to demonstrate quality with tests and automated tests. So in the course, we talk about test-driven development. And this is a technique for approaching your work that builds quality into the software from the ground up, right? And the way you do this is that you write tests that validate that your code does what you expect it to do. And it can be very effective to write these tests before you write the code that's being tested. You have to write a little bit of it. But when you start out with the goal that you're moving towards, especially when it's a small goal, it makes it much easier to achieve that goal. And once you have this suite of tests, it'll give you this, you have this mechanism for getting really rapid feedback on the other things that you changed. So as you add more code, as you change the code, you will know whether or not you have changed the functionality in a bad way, whether or not any of your tests have failed. And you can decide what you want to do based on that. And so it may seem counterintuitive, and I hope that when you'll experience it, you'll understand that by writing these tests, it really helps you go much faster, and you have this confidence because nothing's broken. I don't know about you, but like with me, when I don't have tests, when I go a long period of time without testing my code, I don't know if I've really gotten it right. We've all found those bugs, or we've all written those bugs and then uncover them later, where you're like, oh, geez, I can't believe that I made that mistake, 2 hours ago. It's better to find that mistake, 30 seconds or 2 minutes after you make it than to let all that time go by. So, building software together. In this class, we will experience pair programming and ensemble programming, also known as mob programming, that brings people together to build great solutions to really challenging problems. And for me, there are a number of benefits of pair and ensemble programming. it really lowers the cognitive load. Yeah, we're all really smart people. We do really tough things. We have big brains and we can do all sorts of things. But when you've got multiple people all focusing on a problem, it allows it lowers your individual cognitive load. And then and the way the pair programming and mob programming do this is that in any particular moment, individuals are taking on a specific role. Like one person's job, all they do is like listen to what someone else is telling them to do and type it into the keyboard. And while it might be kind of awkward to do that at first, it really helps you focus, because one person can focus on the language syntax and the other person can say, well, here's like how I want to solve the problem, or here's a good name for that variable, things like that. And as a result of this teaming up, we find our bugs sooner, right? They either never get written in the first place, or as soon as the bug is typed, the person looking over the other person's shoulder can say, or actually the person pairing with them, can say, oh, wow, that doesn't seem right. Or, hey, let's run the test, or let's write a test to make sure that that's doing the right thing. You also end up with code which is much better understood. And there are multiple people that are familiar with it and can evolve it. And I don't know if you've had this experience, but I know a number of times in my career, I've been on a team and there's a piece of code that only one person is familiar with. And if that person's sick or on vacation or in a meeting, you can't write that code because you have no context in it. And this slows things down and this impedes progress. And so then when everybody's working on it, you have just more knowledge about it. And so then you spend a lot more time adding value and doing cool things with the code and a lot less time being stuck wondering what to do next because there's something you're not familiar with. So while we all write a lot of code, if you look at the percentage of the code and the things that we deploy and the things that are running out there, a very small part of it is your individual contribution. And that's not only in the context of Bob and pair programming, but it's also in the context of the larger software ecosystem, so much of which is open source. So, in the last 20, 25 years, there's just been this proliferation of freely available software out there that we can leverage to do even more awesome things. But what this has meant for software developers is that even more so than in the past, we must have the skills to be able to quickly understand other people's code and code that we didn't write and we have no idea who wrote it and don't have the opportunity to talk to them because they're someone on the other side of the world or someone that is largely anonymous. So in this course, we're going to see some techniques for exploring these large software ecosystems. So we'll see standard library APIs that come with a Java programming language that solve a whole bunch of problems for you, and you'll be using those APIs in your own code. And of course, there are frameworks out there for developing applications. In this class, we're going to be seeing Android and the tools that the Android platform provides for developing small device applications. Because a lot of what we need to do is make sense of some part of a very large code base that we're initially not familiar with. We didn't write it. We don't necessarily understand why the decisions were made or even how to interpret what we're seeing. And this is something that while there are good guidelines for you to get started, there is no teacher trying to actually do it. So we'll be learning some patterns that we can then apply in our own code where appropriate. And then also a big part of coding with others and getting at people's code is using distributed version control and sharing our code that way. So a component of this course is using Git and GitHub to share your code with others, to get code from me, to collaborate with each other. And we'll be seeing that. And then finally, evolving code for the future. So again, software is not one and done. Any software that is valuable, that people like, that solves a problem, people want more of it. And this is a good thing, right? This is what we all hope to achieve, is to provide something to the world, to society, let's think big, that solves a problem, a compelling problem, in such a compelling way that people want more of it. And this means that we need to be able to add new capabilities to our software as users demand it. And so we'll be looking at a series of what are called code refactorings that help improve the code, making it more readable, making it easier to approach, for other people to approach it, more extensible, so that new stuff can be added to it. And so for me, those are the sort of the four tenets of contemporary software development. And so while yes, you're writing a lot of code, there are really these larger principles, these larger topics, which is what I really hope that you get an opportunity to experience here over in the coming weeks. Another important thing about this course is kind of the how of this course. If those things were the what, this is the how. The how is Java and Android. And I'm going to be frank. These are not bleeding edge technologies, right? This isn't the latest and greatest, and this is these are well established tools that have been around for a long time, but they really offer a great platform to explore these concepts because there has been a tremendous amount of code written in Java because Android does provide great patterns and a very interesting platform to solve particular problems. There are also very robust tools for building these projects, for refactoring, for doing test-driven development, all these things that we're going to see. And it's contemporary software development. And while for the beginning of the course, we were writing command line applications, partying like it's 1979, we all use software that has a user interface that has something that you can click or touch and drag and things like that. And I want you all to experience that. I know I had the opportunity as a student to do programming. I won't tell you which version of Windows it was on. It was a long time ago. But it was really fun. And it was a different kind of software development that I had seen in my other courses. Not only because it was like, wow, I get to draw pictures and move things around and click on buttons and stuff, but also just the way that I approached the code and the way I debugged the code was very different. And I found it was a really great teaching tool and something that I hope you'll find exciting also. So that was my first introduction. And what I'd like to do now is to get to know some of you. I'd like to have everybody introduce themselves. And folks there, and sorry if you're on Zoom, you probably won't be able to hear people speak. So sorry. But I think what I'll do is I will call on someone here in the classroom and call on someone remotely. I will try to go in alphabetical order. And it looks like we have a pretty even split between them. I just like you to briefly introduce yourself, say your name, if want to talk about sort of where you are in your academic career, that's cool. And what I'd like to know is what interests you about the course and its content, what you're hoping to get out of it, why did you take the course, things like that. And just any questions here at the outset. Yeah, I'll go into more details in the syllabus and things like that. So the answer might just be, we'll get to that shortly. But I'm really curious about what you're interested in. So folks in the classroom, would anybody like to volunteer to go first? Yes, thanks. Hi, Benjamin, welcome.
I'm not a master's student.
Yes. Oh, nice. Where are you interning right now? Nice, good deal. Yeah.
Let's see. This course is
Oh, nice, that's fun. Yeah, you can read about that. Nice. Yeah, thanks. Great. Thanks, appreciate that. Thanks, Benjamin, for kicking us off. Aiden, you're first here on the list. If you wouldn't mind coming off mute and introducing yourself to the class. I don't think we've done, and video is awesome too.
My name's Aiden.
Oh, wait, you know what? I'm sorry, I don't have the Zoom audio going through the speaker. I forgot to check that. Select speaker. Could you try it again, please?
Yeah, can you hear me?
Yeah, it's good.
Okay. Hi, my name's Aiden. And then I was just taking this class because I wanted to learn about Java.
Right on. Thanks. Any second volunteer here in the classroom? Otherwise, I'll pick on somebody. Yes. Awesome. Thanks, Nora. Yeah, we've got a lot of foundation to lay before we get to Android, but it's at the end of the course, and I think by then you'll sort of see the culmination of everything that you learn come there in the Android app. Thanks. Let's see here. Cameron, you're up next on the list. Would you mind coming off mute and introducing yourself?
Hello, my name's Cameron, and I'm a senior right now, and my main interest is probably like mobile applications.
Awesome. Yep, we'll definitely get into some mobile stuff. Nice. Third person here in the classroom? Yeah. Great, thanks, Sid. Have you had experience with Java before? Oh, nice. Okay, I wasn't sure. So they're still teaching Java a little bit. Yeah, some no's maybe. Yeah. Okay, pretty minimal. What we'll talk about sort of. Oh, is it now? Okay, so like it used to be Java and like they recently switched. Okay. Okay. Well, good. 'Cause that's one of the questions I had about like how much familiarity we do have. One of the first assignments is what's called the Koans. We'll learn about tonight, which I've found to be a very effective teaching tool for like learning the language and understanding the syntax and stuff. And so either if you're new to it or it's been a little bit while, it'll be a good opportunity for you to dive all into it. Yes. Let's see here, John C. If you wouldn't mind coming off mute and introducing yourself.
Hello, can you hear me?
Yes. Hey.
Oh, I'm in the library right now. I didn't realize we met in person.
Oh yeah, totally. Yeah, if you want to bop over to Carl Miller 380, we'd love to have you.
Yeah, probably do that during the break, or I'll do that after I introduce myself. I'm a senior, just want to learn Java, and like you said earlier, building apps and something with screens and UIs and not just command line stuff. So I'm really interested in.
Great. And you know what? I realized, yeah, I didn't put the classroom on Canvas. And the reason I didn't do that is I couldn't find out where the classroom was. I'm like, okay, it used to be like, was it on a spreadsheet someplace? So it's like, where? And like, I almost emailed the department chair. I'm like, no, there must be a way for me to figure it out. And then like, oh yeah, you go to this. For me, it was like under some like your personal schedule section of BandWeb or whatever. I'm like, oh, okay, yep, there it is. So sorry about that. And if those of you who are remote want to use that as an excuse for like why you didn't show up, that's fine. That's good. Awesome. Well, thanks, John. Next in the classroom. Yep. Oh, nice. Mm-hmm. Yeah. I've had a similar experience with Java where, yeah, it's strongly typed. And while, yes, that means like more syntax and sometimes the types get a little complicated and stuff, for me, it's so much easier to approach like a strongly, somebody else's strongly typed code than it is to try to understand, like, when I see Python, I'm like, okay, what's that method do and what is it, and like how to find the documentation. And maybe it's just because I don't have an experience with it, but yeah, I like my types. And so you'll get a chance to experience strongly typed Java to see what it's like for you. John L., you're next up on the list.
Hey, yeah, obviously my name's John Lorenz. I work at Intel, and funny enough, I'm actually kind of displaced from software because I work in the manufacturing side, but part of why they brought me on is actually to integrate more software. And while they don't necessarily use a lot of Java, I've found that in the past that changes, and that kind of leads me into the interest of this course. I've actually taken the advanced Java course, and I really like the structure of it, so I wanted to continue that over into the new naming scheme here of the contemporary software development. And I mean, in the past, I've kind of I've kind of discovered that even though you don't necessarily intend to use a specific language, sometimes you end up using it. And in that case, for me, at my previous employer, that was using Java for a computer vision application with machine learning. So it's just one of those things. It's a good skill set, and I like the content, and that's why I'm here.
Awesome. Cool. So wait, you took my advanced Java programming course?
I did, yes.
Okay, good. Please reach out to the department to make sure that this will count, because it's a lot of the same content. And I said, well, it's because they asked me, well, can students take it? And I thought there was supposed to be a block on that. just for your own,
Yeah.
make sure you get credit and that you're using that you get your money's worth out of it.
Right,
That
I'll find out.
You'll get that. Yep.
Yes,
Awesome.
thank
Cool.
you.
So it's good to see you again. Glad you came back.
Yeah.
Awesome. So you wanted to yeah.
So I'm using Meta, and I was interested in this course because previously I've been web development and user interface network, and I thought it was interesting skills for this, and really other applications across platform.
Nice. Yeah, it's interesting. I was thinking, is Java some of the right, language for this course and everything? Because I mean, they're not really teaching it that much anymore in lower division and everything. And for me, just like having that user interface portion of the course is so valuable. And I'm like, well, maybe I could teach JavaScript or anything that's like, wow, that too is a lot and everything. So, but yeah, I'm really interested to hear about your experiences working with the Java technologies and Android and how it compares to what you've done with web development. Super cool. Let's see here, Katie, you're up next on the list.
Does that work? Okay. Hi, I'm Katie. I guess it just sounded like an interesting course. I needed a programming intensive course, and I'm a returning student, and yeah.
Awesome. And program intensive this will be. To be clear, you'll be doing a lot of coding. You'll be seeing a lot of coding too, right? This is what we do. It's a course in software development, and while we do talk about these topics, we apply these topics. And so then, while tonight you're going to hear me talk a lot about words, starting next week, I'm going to be coding in front of you. I'm coding with you as we explore all these topics together. So great, looking forward to that. Let's see here, who else in the classroom having? Great. Okay. Yeah. Well. Yeah. Hopefully you'll get that. Let's see here, and then so finishing off because I think we've had everybody in the classroom. Yep. A couple more people online. Michael.
Hi, my name's Michael, and I needed a programming intensive elective, and Java sounded interesting, so now I'm here.
Great. Awesome. Thanks. Hey. Thanks for showing up, John. Let's see here, Natalie.
Okay, it worked. Hi, I'm Natalie. I'm post-bac. And I spent several years doing tech support for a mobile analytics SDK. And one of the favorite parts of my job was whenever we came out with a new feature, I'd build like a half dozen little test apps for Android and iOS also, but I liked Android better. So I could understand what was going on and help people. And so when this came up as a possibility for an elective, I was actually really happy and excited because it was one of the favorite parts of my job.
Awesome. Yeah, and so now you'll get to experience the developing the app, being on the other side, and I bet yours are going to be really well tested too. So super cool. Excellent. Thanks. And Sharon, I think you are last on the list.
Hi, I'm Sharon. I am a manufacturing engineer at Nike, doing masters here. What interested me about this class, I just took the software engineering class from Professor LeBron, got a little bit of flavor of software development. I thought was really interesting, wanted to explore that in building an app. So I signed up for this class.
Excellent. Welcome. Well, thank you all for introducing yourselves. We'll be working together this term. Yeah, I mean, you'll be hearing me speak a lot, but you'll all have an opportunity to work with each other. And it's important. Again, this is a team sport that we're playing, and I hope we get to make connections and then work together on writing code and learning. Okay. So a little bit more preamble. This class was marked as hybrid. Ever since we came back, or we've been able to come back on campus, the last couple of times I've taught, I had the attend anywhere option, where that was a good option for people, especially in the first few months when we weren't sure, what exactly would happen when we started interacting with each other again. We no longer have that option, and so this is the first time I'm teaching as a hybrid class. So I just want to talk about that and what it means. So we meet. I'll be here, and I hope many of you will be here at here in the classroom at 5:30 on Wednesdays. And what we'll experience together here is our in-class discussions. I'll be demonstrating some stuff. We'll be seeing demonstrations, and then in-class activities. And so then we'll have another one shortly here after our break. But I broadcast the class over Zoom primarily because it's the easiest way to record it. And I will post the recordings on YouTube so that you can review it later, because a lot of stuff goes by. And I know from my own experience as a student, there were times regardless of what kind of notes I took or whatever, I took notes on paper, as you can see. They were like, oh, what did the professor say? Or someone asked a really good question. Now I have that same question. I don't remember the answer. I want that resource to be available. Now, I also broadcast it because, hey, we've all got lives, or sometimes that we can't be here, and sometimes it doesn't make sense for us to be here. I want to have the option there. So there are some classes, some meetings where your presence is required. So we'll talk more about it in a couple of weeks. But we have pair programming and mob programming activities that we do, and I'd like those to be in person. And so there are 3 mob programming activities on the 24th, the 31st, and February 7th. And then there'll be 3 mob programming activities on the 21st, February 21st, 28th, and then March 13th. I'd like you to attend, or actually you must attend, 2 out of the 3, so 2 mob sessions, 2 pairing sessions, so that you get multiple opportunities. You don't need to attend all 3, but 2 out of the 3. Otherwise, attendance isn't mandatory. If I was doing this, before, when I did this before Zoom, or if I wasn't doing this, I don't have attendance. We're all adults here, right? We have lives. One of the things that you learn to do when going to college is how to manage your time. And hey, there are some Wednesday nights where you can't make it. Stay at home watching Felicity or something like that. You're all adults. You'll figure it out. And so then, that being said, I want you to be engaged in the course. And I think you'll have a better experience maybe easier to be engaged if you're physically here, interacting with people and looking at that. But that's not always an option, and maybe it doesn't work with you. And so then, here again, the reason this is hybrid is that, sure, most of the time, if the right thing for you to do is not be here, okay, you don't have to be here. It'll be recorded. You won't necessarily get the same experience, but again, don't take attendance. It's not going to impact your grade. Otherwise, otherwise, I would like you here though for 2 out of the 3 pair and mobbing for activities. Any questions on that? No. Okay. Well, cool. Oops. Is the last slide? No. Oh. Okay. I think I skipped one. Yes. Okay. So I'm very curious. I've never been a student where they had all this remote learning, right? They didn't. Back in my day, our idea of remote learning was there was a lecture recorded on campus, literally on a bank of VCRs, and we post-mailed the cassettes to people. That was remote learning back then. This is so different, and it's so much richer, and we have so many more opportunities, but there's still a lot that we don't know about it. So what I'd like to do is I'd like you all to break up into small groups. What I'll do is I'll create 2 breakout rooms in the Zoom, so we get, 4 or 5 people in them, and then we'll divide yourselves up here. We've got 4 and 3, or however. And there is a Google Doc that, so I'd like you to have a discussion about what your learning experiences have been like. I think you've all experienced, fully remote, and then sort of, all hybrid, and then also in the classroom. And I want to know what works for you, what you found in terms of the learning techniques and the teaching techniques that are effective. So I have here, there we go, here's the Google Doc. I'll post it here in the Zoom, but also on the Slack for the class. And hopefully someone in each group has that also. You don't want to type this whole big URL into your computers. But let's take, I don't know, let's take 15 minutes because we're all getting to know each other, and work in our small groups, and then we'll take, I don't know, like 10 minutes after that to do a report out because I'm really curious about what you found. So just, oops, I guess so everybody in the classroom can see it. So what I'd like you to do is just brainstorm a list of things that have worked well when it comes to hybrid learning, and things that haven't worked well. And then if you've got any ideas that you'd like to apply in this course, so things that I can do to make your learning more effective, I'd like to know all of that. So your access was denied? Oh, are you logged in as PSU? Well, actually, I can probably just open up with everybody. Oh, I haven't shared it with anybody. That would do it. I don't say anyone with a link. Could you please try it again? Great. Awesome. Thanks. Okay. Okay, I'm going to pause the recording and we'll be back in a little bit. And I'm muted, thank you. That was a hilarious joke. You missed the uproarious laughter in the classroom. So what I'd like to do now is have a quick report out. So I'd like to ask each group, or or a representative from each group, to talk about what they discussed, and maybe if there are any similarities of what was discussed, any themes, or maybe there were some points where people had different points of view they'd like to share. And let's start with this group here in the classroom. Over there, and I'll try to amplify what you're saying from the people who are remote. So what have your experience has been learning is like what's been effective and what hasn't been? Mm-hmm. Yeah. Mm-hmm. So yeah, so here's what I heard. So that in your group, yep, there are some people that preferred in person, some people preferred remote, and for interesting reason, right? People felt that when it comes to their individual focus, either online or in person worked better. And as you pointed out, professionally, yeah, a lot of us aren't in the same room with people, and so then developing the skills to be able to communicate effectively, both making our own points of view be known, and then also understanding other points of view. Yep, it's fun. Thank you. That's great. Now I'd like to call on the people who are online and have one or two of you come off mute and talk about the discussion that you had and the things that you felt worked well and the things that maybe haven't worked well when it comes to in-person versus remote or hybrid learning.
I'll do it.
Thanks, John.
I kind of brought something up earlier, but I mean, I feel like in person you definitely have an advantage of the access to the resources you need to learn in terms of intensive resources that you just can't really get from an email, an IM, or even a Zoom meeting. And that just comes down to communication standards and how it's way better in person. It kind of always will be. I think the biggest hurdle that people run into, and myself included, is just making the time to engage in the activity of moving your physical presence from one location to another, especially if you got it's right in the middle of your job hours per se, right?
Yeah, totally. Excellent. Other perspective from people who are on Zoom that you'd like to share?
Yeah, what I heard is both remote or in person could be a great experience. It really depends on the professor at times. Yes, and for me personally, and a lot of people who um, have a full-time job, the flexibility is just better if we have both like recorded and the option of getting there if we need to. So I think just yeah, the flexibility is huge, especially because parking is hard and getting there is hard if you're not near Portland, your living space.
Great. Great, thank you for sharing that. Yeah, very good. All right. The other group here in the classroom, what are some of your observations, and what are some things that maybe, yep, you could all agree on, maybe some things where there wasn't so much alignment? Hmm. Thanks. Yes, I think yeah. I mean, there are different kinds of engagement that you get when you're in here and when you're all dispersed. And then yes, just the having to go from wherever you are at one point during the day down here. I guess it never really occurred to me how much easier it is to take a class during the day when you also have a job. Because there is no driving down here or anything like that. So that's good. And yeah, and safety, right? It's dark. And we're down Moreland, and yeah, I mean, if you have to, walk to the bus or the train or whatever, that can sometimes be pretty intense. So, excellent, cool. Well, thank you. I really appreciate you participating in this. I'll read over these here. Actually, I want to look at the ideas for the course. So, and I just want to maybe get some feedback on these now. Yeah, remote office hours. Yeah, I mean, on that. The department asked me, "Hey, when are your office hours?" I'm like, "An hour before class, right?" I'm available anytime. Well, I'm sorry. I can. I'm flexible with my scheduling, and so then as we talk about, I'll just say it now. So I try to keep on top of the Slack. I definitely check the first in the morning and then in the afternoon or the evening. But I can meet in the evenings via Zoom if you need to. Maybe I can do it during the day if my work schedule allows it. But yeah, definitely, I think that makes sense. That's an easy one, especially this is one-on-one. It's not like it's the classroom environment. Combination for engaging, hybrid, Slack, all the things. Yeah, as we'll see, all the resources are out there and accessible and can be accessed at any time. And here again, we'll do things like we do tonight, right? Where we'll work together, we'll work individually. You'll hear me talk, you'll work with me, things like that. Access to the group activities online. That's something I'm open to. So in a couple of weeks when we talk about the mob and pair programming, I'll think about it a little bit, and then let's have a discussion about if there's a desire to experience remote pairing and remote mobbing. That's something I'm open to. Something I've done it in the past with mixed results, and so then we can talk about that. And then yeah, the chat and discussion. We have the Slack channel. In years past, I've created like my own Slack workspace. But it's just more to manage for you all and everything. So I'm trying it, and because there's only 20 of us, I'm using this contemporary SW development with Java and Android channel. So yes, I will. So this is a place where you can ask questions of me. I'll probably respond here first before I respond to individual IMs. And if there's a really good question in a direct message, if there's a really good question in a direct message, I'll probably post the answer here for everybody to see, because most of my experience has been is if one person has a question, probably more people have that question. Because twice I wasn't clear on. Great. So yeah, so there are tools. So the way I look at it is that we now have more learning options available to us, and I want to try to provide a learning environment that is most effective for everybody. And so then we've got lots of options, and we'll discover more as we go. Cool. Okay. Thanks for doing that. And I think it's time for a break. I've been talking for a little bit. Let's just take 10. And so we'll be back at 6:40, and then we'll dive into the syllabus and some stuff like that. So I'll pause the recording and pause the sharing, and I'll see you in a little bit. Hey, everybody. Welcome back. Thanks for coming back. Glad you all made it. Hey, so far we've talked about the high-level goals of the course, got to introduce ourselves, know each other a little better, talk about our experience with remote learning. Now we'll dive into just more details about the course. And actually something that I want to tell you about this course that's really not in the materials. So as like John L. noted when he introduced himself, he took this course from me called Advanced Programming with Java. And that was like the earlier evolution of this course. So, that's the course I taught for a number of years, and it started out being just mainly about Java. And then I realized that what was really valuable is all of just the general software development lessons that we learned. And so then I've renamed it, rechristened it, if you will, Contemporary Software Development, Contemporary Software Development with Java and Android, blah, 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 very long name. But one of the things that you'll notice in some of the course materials, especially the screencasts, they still refer to the old name because they're from the old from the old course. So very relevant to this course. But you'll probably see that. And one place I noticed it is that the course webpage is still called, at least the title of the HTML is Advanced Programming with Java. So I'm going to fix that right now because I'm really trying to make it clear that this is a different course. So I'm just going to. Anyway, so if you see contemporary software development, let's see, university, save that, make sure it takes. Yay, it's got a new name now. And now I will commit this to GitHub. Put the new name of the course in the HTML title tag. So anyway, you'll see that in some of the screencasts, maybe in some of the lectures if I miss things. I apologize if it's confusing, but like I said, I'm still in the middle of evolving the course. I recorded a number of I updated and re-recorded some of the screencasts, the ones here at the beginning, but I think the ones later in the course I just haven't gotten to yet. All the information is still relevant and correct, although the screencasts themselves are pretty old. Okay, so before we dive into that, I just want to talk about what we're doing next. So I want to cover the course syllabus, always an important thing to do on the first day of class. Then we'll get into it. We'll see how to use Git and GitHub to start working on the project. So you'll get your first project assignment tonight, along with the Java Koans. And then both tonight and next week, we'll be developing this simple student project, student program, and we'll be using test-driven development. And so then I hope to be able to do some introductory stuff tonight with that so that we're in a good position for next week. And that's, I think, everything from the slide deck. So we are done with this slide deck. And in general, I won't have slides to present. I'll just talk and really show you code, because I think that's the most interesting stuff. Here is the course homepage, and this is what I use as home base for the course. There's stuff in Canvas, and for me, anything that has like a due date, I want in Canvas also. I'm sure that that you use Canvas to manage like your academic calendar to figure out when your assignments are due and when the quizzes are and everything like that. And so then those things are in there. But when it comes to the lecture notes and the screencasts and everything like that, you'll want to go to the homepage for that. It's just easier for me to manage this than it is to update stuff in Canvas. Basically, this has the big course schedule here. And so this is a mixture of like the projects that get assigned, probably very more importantly, the lectures. So the background material for the course, I've all recorded and put up on YouTube. So if you are new to Java or would like a review of the Java programming language, I have slides here that I then, if you like reading, if you learn best that way, you can read the slides here, but then I also speak to the slides in screencasts that are up on YouTube. I've got a, hi everyone, Kermit the Frog. That's my voice, sorry. I also have a playlist here on YouTube of everything, so you can go through that. But I expect then that just as if you had a textbook and had to read the textbook, that you spend time outside of class reviewing the slides, either watching the lecture if you learn well when someone's talking to you, or if you just prefer to read them over and then do additional background research, that can work well too. So then normally I won't be I don't lecture the slides. I did that for many years and got to the point where even I was bored of it. And I'm like, oh my gosh, if I find this stuff dry, I can't imagine what it's like for the students. So put all that stuff on YouTube, only had to record it once. That way, and then also you can watch it at a time in a place that makes sense for you. The things that I sort of expect you to have coming into the course, or things you might want to start reviewing now, are the Java programming language things, and then also source code management with Git. Now, how many of you have had experience with Git and GitHub? Everybody just about? Okay, that's good. Part of what we learn here is about source code management. I thought it was a really good place to start. So I would encourage you to review this, even if you're kind of familiar with Git. It talks about branching. It talks about remote repositories, which maybe you've used before, but haven't really understood why. It's new material for the course. This is new this year for the contemporary software development. I'm really curious about how it augments or maybe duplicates stuff you already know. So please feel free to reach out on Slack with any feedback you have about the Git lecture. Let's talk about the syllabus. So I talked, at the beginning of class about the sort of concepts. Let's get into brass tacks and really talk about what this class is all about. So here, what we're looking to do is to explore topics and concepts in contemporary software development by applying them in the Java and Android ecosystems. So, we'll be learning about test-driven development by writing test-driven Java, for instance. Here's how we're going to do it. So, like I said, the lectures are all delivered asynchronously. They're on YouTube. Watch them when it makes sense for you to do that. Although, please keep up with them because the assignments are timed based on them. But we'll also have in class here, we have discussions, we have demonstrations. I'll be demonstrating things to you, and then we'll be also working together through pair and mob programming. Your individual work in this course will be a multi-phase project. We'll get the first part of it tonight, and the whole idea is that you build up a project over the entire course. I think there are 6 phases, in the 11-week course. And you apply these concepts that you learn, like learning how to leverage the standard Java API and work with those classes. Again, that code that other people haven't written. And making sure that it's well tested and working with files and formatting dates, all sorts of stuff like that. So, and then culminating in the Android project. And in your Android project, in the last project, you'll be working with code that you'll start writing tonight. And so you'll really get to see an application evolve in small increments over the course of the term. And then your other individual work is the quizzes and exams. Those are administered over Canvas, and there are, I think there's 7 or something, 8 quizzes. So there's about 1 a week. There's other stuff too. So the things that we're going to cover, we'll be looking at the standard Java libraries. So we'll see how to leverage the utility classes, how to do I/O. do XML formatting, parsing, things like that. We'll be seeing a lot of unit testing and test-driven development for Java programs. We'll also be experiencing how to work together and learning. I guess there is lecture content with this. The first few times that I injected test-driven development and pair and mob programming into the course, I didn't provide a lot of context, and I don't think the students got as much as I had hoped out of it, as I intended. And so then, later in the course, there are lectures, about pair programming, where I talk about the structure behind this. And it isn't just like two people working together. No, there are roles that you take on, there are techniques you can apply to have effective pair and ensemble programming. We'll be learning about web application development, and this is back-end web application development with REST API. So you're not going to be writing HTML and JavaScript and CSS and everything like that. This is sort of the server side of the web application. We'll be talking about testing with mock objects and how you can then leverage that for web application development. And then finally, we'll be learning about Android by building a small device user interface. And we'll be using the Android emulator, so you don't need to go out and buy an Android device. It might probably be faster if you use the emulator, faster to develop anyway. But hey, if you've got an Android device and after you've built your application on your development machine, if you want to plug in the USB and send it over there, you can do that. Students have, and it's kind of neat to see your own work on your phone. So to provide structure to the course, I have these grading policies. So 60% of your grade is the multi-phase project. This is a course is a program-intensive course. It's all about software development, and so therefore, the majority of your grade is the code that you write, and the correctness, and the correctness of the application that you write. 21% of your grade is the quizzes. Each quiz is worth 3%, and I dropped the lowest grade. Those are all administered over Canvas. And the quizzes are related to the content of that week. So I think the one for this week is all about Git, because that's one of the lectures and the thing that I expect you to kind of come in here with some experience with. Now, as I said, there are those 2 required mob programming and 2 required pair programming activities. And the way that you're assessed on those, in addition to your participation, actually, so it's participation, you got to be there, you've got to demonstrate that you've made a contribution. But then also what gets graded is a reflection on that. So I'm basically going to ask you about your experiences and what you thought about it. Yep, and so then, sorry, the verbiage here is a little confusing. So there are actually 3 opportunities to pair program, but please plan on participating in 2 of the 3 for each, and once this all makes sense later. And then there's a Canvas quiz for your reflection. The final exam is worth 12%, and this is sort of an indication of those do all equal 100, right? 7? No. Oh, it does. Good. This is an indication of hey, listen, you have to do the final exam. It is comprehensive. It is a demonstration, but it will not determine whether or not you pass or fail, right? There are lots of opportunities to contribute to your grade in this course. There's lots of things that are assessed, and so then, hey, if you mess up on one of the quizzes, it's 3%. Probably not even a letter grade. If one of the first projects you don't do very well, it's much easier to make it up. It's pretty easy to make it up over the course of the term. And then in the final exam, hey, if you're having an off day or you don't do well there, you'll still pass the course. So this is by design. I want to make sure that that you either don't blow it all on one, or that you all save it up to the end. It's like, great, all I need to do is pass the exam, nothing else. Nope, it doesn't work like that in this course. You gotta stay engaged throughout. Now, that being said, there's a lot. And hey, there are some weeks when your other courses are lighting up, or you got other stuff going on in your life where maybe you can't provide as much focus as you'd like. So then when it comes to project submissions, I do accept a little bit of late work. You have 2 late days to use on any project during the term. And I also let you resubmit one project without penalty within a week of the original grading. So this is, hey, if you misunderstood one of the requirements, or you just had like a fundamental bug, and then all the test cases that I run it through fail, I want you to make sure you can, learn from that and still get a good grade, and so you can resubmit it there. Otherwise, my policy is not to accept any other late work. That's what I have to write on paper. But I'll tell you now, I want you to be successful in the course. And so then, please let me know if it's like that really rough week for you, or hey, there's something that you're struggling with. I can be flexible to a point. And really what I look for is, students that are trying, that are engaged, and that do the work. Over the years, I've had a number of students that show up in the last week. It's like, oh, hey, can I resubmit project one? It's like, no, it's too late for that. And so then, this is the policy that's stated on paper, but in practice, I want to make sure that you can be successful. Oh, I guess one other thing. I don't have any graders this term. It's great to have a small class, and I'm excited about that because I'm hoping to have an opportunity to interact and like learn your names, because I don't have 60 students, I only have 20. But I also don't have anybody help me grade all of this, and so then I think I can do it all, and I'll try my best to provide feedback in a timely fashion. But there might be some times where it's like, hey, sorry, I can't. It'll take me a day or two to get to the resubmit because I've got a lot of newly submitted stuff to grade. By policy, I grade on a curve, but I haven't had to apply the curve in many, many years. We'll see with smaller students, maybe this will be the term. But because there are so many opportunities to contribute to your grade, I found that things even out pretty well, and that I just crunch the numbers and it's like, great, you get a 90, yeah, it's a B+. Yeah, because really even on the grade, that's about the 30% point on the bell curve. So that's fine. So the undergraduate and the graduate sections of this course, it's the same course. Sorry, I haven't put in the effort to figure out how to differentiate between the two. I think they're both quite challenging, or rather, I think that they're appropriately challenging for both undergraduates, upper division undergraduates and then graduate students. But if there is a curve, each section will be graded on its own curve. And I think with 20 students, I think there's only like 6 graduates here. I'm not going to try to grade, to curve that differently than I do the 14 undergraduates. Those are the grading policies. Any questions so far on this, in either the content or the grading policies? Everything makes sense, I hope. Yeah, okay. Nothing for people online. Don't cheat. I feel like to be like, lawyerly and say, yeah, don't do that thing you're not supposed to do. Haven't had any cheating problems in a couple of years, but there were a couple of times where it was clear that people were cheating. I use this tool called Moss, which comes out of Stanford. It'll be a long time ago, but it's good. At techniques software plagiarism, and sort of just gives you that side by side. It's like, look, this code is the same, it even knows like if you've been renaming variables and changing comments, and so anyway, don't do it. And I'll talk more about that. And I'll also be clear on the quizzes. Yes, I administer them online, and that's for everybody's convenience, including my own. And actually, it makes it so that you don't have to come to class and do paper and stuff like that. But while you're doing the quizzes are your own work. You may not consult any online resources. So you can't ChatGPT it. You can't use Stack Overflow, and they're not open book. The final is, but the quizzes are not. They are meant to be your own work, just using the knowledge that you've had gathered in your own head. And because I'm not watching over you while you're taking the quizzes online, which you may do at any time the week before class. So for instance, I think the first quiz opens tonight, or maybe is already open and is due next week. So you can do that at any time. Again, makes it easier for everybody. But I do request, although I can't enforce, that it be your own work. Again, back to cheating. The department's definition is it's cheating to submit for credit work that you did not create or allow your work to be submitted as a work of another student. This is something I always kind of struggle with because like we talk about like pairing and like working together in this class. And you can close that door if you want. I don't know if there's a draft coming in either. So, here's my thing. You can talk what you want. You can, chat in Slack, draw pictures, go to the whiteboard, do that kind of stuff. Just don't look at anybody else's code. Let's be honest. I can't detect plagiarism in your ideas, but I can in your code. So just don't look at anybody else's code, and that'll be it. Also, please don't commit your code to a public GitHub repository or any public source or any public forum. Right? This is just keep your code to yourself. No. There is some work in this class which is meant to be open, and that's what the mobbing is all about. The pairing is all about. My code that I write in front of you all. Anybody can see that, and you can use that. Right? Hey, someone uses an API or writes a little bit of code in a kata and one of the mob programming exercises. You're like, wow, I'd like to use that in my project. Yeah, go for it, no problem. That's not cheating. The stuff we do there. However, the projects and the quizzes and the other things that determine your grade is meant to be individual work. And if you have some question or concern, because several years ago I had like a bunch of students where I'm like, you all cheat off each other, and they're like, oh, I thought we could mob program for the projects. I'm like, no. And so that's why I'm making this extra clear here. But if you're like in some situation, you're like, oh, hey, we both had this great idea, or hey, we were writing some code on the boards. Okay, just reach out to me. We'll figure it out. I'd much rather know beforehand than to have to confront you after the fact, because it's just not pleasant for anybody. There is an official academic misconduct page. If you haven't read it, you should. It's kind of interesting about what they, about the boundaries that they set. This is the first time I've sort of taught in the age of ChatGPT and all these other AI assistants, Copilot, things like that. If you're interested in using one, I want to talk about it with you because I have to admit, I don't use them myself. I can't use them at work. Professionally, we can't be sharing like our proprietary source code with these online with these online tools. We have no idea where that goes. And so I don't have a lot of experience with it. So I don't know what it can do. Presumably, you can't just like give it the PDF and have it write your project for you. If it could, that would be a really interesting case study, right? I'd like to know more about that. So if you're thinking about using one of these, let's talk about it. Not right here now. We've got a lot of stuff to do, but we'll chat about it offline. And because really, I'm curious about the kind of learning experience that those tools can enable. Lots of other things. I'm sorry. I always feel like I belabor this point, but any questions about the academic integrity conversation? No, good. Yeah. Again, the lecture notes and the screencasts, they're linked on the website. They're on my YouTube channel. Please review them before class. And, they're also good to have in class. Again, if this was a long time ago and we all had pieces of paper and stuff like that, we all be able to see them. It's good to have access, while we're talking about things. The projects, especially the first couple, might seem straightforward, but history shows that they aren't. So please don't wait until the last minute to start them. We'll be talking more about this next week, but I recommend that as you're writing your code, write the documentation for it. It helps that to express it in natural language, in spoken language or written language, in addition to being able to express it in a programming language. Please ask questions. I already know the answers. That's why I'm teaching the course, and I'm not saying this just to hear my own voice. You just heard my recording of my own voice. It's awful. So that's not why I'm doing this. I'm here to help you learn. Yes, you asked a question during the questions asking session.
Yeah, I was wondering, when you said document it, so you just write it?
Yes. We'll dive more into it in a handout next week, but there's a handout on the site that talks all about it. If you want to get a head start, there's the this is week 2, how to document your projects. Basically, I have some requirements for the documentation that's there in the code, and then also some documentation that you submit before the project's due and stuff. But the goal here is, again, this is like just a part of what we do in contemporary software engineering. We communicate what it is that we're going to do. We and what we have done. And so, yeah, that's a component of the course. Sorry, I didn't point that out. That was how to document your projects. Probably looked at it, but didn't mouse over it. So please ask questions too. It's all part of the learning process. And here again, my experience has been is that in basically every instance, if one person in the class has a question, someone else has the same question, and they really appreciate it when you ask it. There's programming intensive. This is a programming intensive course. There's a lot of work in it. It's a senior level course for your undergraduates. It's a graduate level course for graduate students. If you're taking other courses that have a lot of heavy workload, the operating system, operating system compilers, they don't have compilers anymore. But there are also other courses out there, and if you're taking them, make sure that you have a plan for this term that you can achieve. You don't want to find yourself in a position where you're going to make some difficult choices, or you find yourself that you're behind in all your classes. There's lots of code examples out there. You'll see them in the lectures. They're on my GitHub. They're there for you to play with and to learn from. So feel free to work with them. Like I said, my office hours are, strictly speaking, the hour before class via Zoom or whenever. Or wherever. I'll probably be here in the classroom. But if you've got a question, reach out on Slack. If you want to meet with me and discuss in real time, I'll try my best to accommodate it. I can usually find some availability on most days. This is no longer accurate. Yes, we'll use Slack. We will use the PSU's Slack channel. There's a link for an invitation both on the Canvas homepage, and I put one in the Zoom chat earlier. If you want to get in touch with me via email, I still have one of those cs.pdx@edu email addresses. This is just my last name. I like using it. You can also, but do not email whitlock@pdx.edu. That's not me. That's like some dude in like the art department, and his name's also David Whitlock, so it shows up like which is super confusing. My pdx.edu email is whitlowcd. So close. And so anyway, so if you need to share a Google Doc with me or whatever, that's the email to do that. I have a separate Linux account and a separate email address for the grader, and this sort of just helps separate things that are graded homework versus things that you get from me. But some email systems have been known to mark it as spam. So then if you get a message from me on Slack saying, hey, I graded project 1, and you don't see your grade, and we're expecting one, check your junk folder first, and then if you don't see it, then please reach out. Again, I consider that the course webpage is the authoritative source for information about the course. I try to keep things synced between that and Canvas, but sorry if there are mistakes. We'll be talking about the survey.sh script before, but what you need to do there to get set up. But please be sure to do that. You have to do that before you, actually, not only before you submit the project, before you create the projects. This is something that we'll be talking about shortly, but it helps me know who you are, and it helps me record your grades. Because one of the things that I realized a while ago as the course started getting more and more popular is that I needed to, in order to scale to all the students that wanted to take it, I had to automate some amount of the grading, but also just the recording of the grades on the bookkeeping and everything like that. And so then running the survey scripts helps me get started with all of that. And that's it. So that's the syllabus. Those are sort of the high level concepts of the course. Any questions remaining? Any topics that I didn't cover here that you're curious about? Nope. Yeah. Yay, okay, so I think that's enough of me talking at worries. I'll be talking at code. So, I use GitHub to store all my code. And of course it uses Git to do the underlying management stuff. And I created, I'm going to post this in the Slack channel. So here is the getting started repository. So there's a lot of, there's some setup to get started with this course. No question about it. And over the years, I've tried a number of tactics to sort of, get people going, because, here at the beginning, I don't want you struggling with the tools. I don't want you to have to, learn a lot of like command line arguments and stuff like that before you can get started. I'd like you to get just started with the code. So I've developed this getting started repository that has a whole bunch of instructions for what we need to do here. And so this will walk through like what we need to do to use this repository, and then also what we need to do to use Java, also things like that. And so I'm going to walk through that now. Feel free to play along in real time. If you've got access to a laptop, I'm happy to answer questions that come up along the way. Or if you sort of want to watch it all go by and take notes of things that you think are different or unusual, and then use the recording of the class to recording or follow these excellently written instructions to do it on your own, that's fine too. So this repository helps you get started with the course. And the whole idea is that this is what's called a template repository in GitHub, and you can create your own copy of it in your for yourself. And then you will use your copy of the repository to then do your projects and commit your code to GitHub and things like that. So actually, I think I want to have this open in 2 windows so that I can, what's this one? Oh, I already do. Oh, gosh, okay. Okay, so the first thing that you need to do is get access to GitHub, which maybe some of you already have as part of your previous classes or just on your own. You can get a student developer account, which gives you private repositories. So the whole idea is that hey, you've got a bunch of code is under source control. It's in something called a repository in Git, and then GitHub makes these available online on the internet. And repositories can be public or private, and we've got a private repository. You can control who else can see it. Public repositories are available to anyone. So the first thing that you need to do is create your own GitHub repository from this template. And so you do that by clicking the Use This Template and say create a new repository. Okay. And it's going to then say, hey, what type of repository you want to use? Yep, my Portland State Java Getting Started. You don't need to include all the branches. Now you don't need to do that. And then you choose where you create it. You want to create it in your own organization, and then the repository name, something like Portland State Java Winter 2024. You can of course call it whatever you want. You can give it a description if you want. So, code that we write in contemporary software development. The next time I teach this course, it will have a shorter name. In the winter of 2024. I'm going to make mine public so that you all can see it. You, however, should make yours private. Actually, you must make yours private. Otherwise, then anyone will be able to see your code. You don't want that, because that way, that people might cheat off of you. But yeah, you'll make yours private. I'm going to make mine public so that you all can see it. I'll create the repository. And so what this does is it takes my Getting Started repository and makes a copy of it for you to use. Yep, and here we are. And so it says, yep, it was generated from this thing, from the Getting Started repository, and it's called Portland State Java Winter 2024. But it's got all of the files that were in my repository. It doesn't have the history of everything that I created, and that's fine. You don't need a whole bunch of commits from me in your repository. Okay, so we've got that. I'm going to go back to the other tab here and talk more about what this is all about. Oh, and by the way, I highly encourage you to make me a collaborator on your private repository. If you've got a question, it's much easier for you to ask it and for me to answer it if I can see your code. And so especially like, hey, this thing isn't compiling, or things are broken. Can you help me? I have a failing unit test. Can you help me debug it? If I can see your code, I'll be able to solve it a lot easier. I might even be able to create what's called a pull request, where I can say, oh yeah, right, to fix this compilation thing, just change this code here. Or it's like, oh yeah, you broke this thing over here, and here's how to fix it. And so then you can click on this link to do that. And my GitHub user ID is David Whitlock. That's me. Okay, I've created the repository on GitHub, and now I want to be able to work with it locally. And so then I need to make what's called a clone of it. And I'm gonna do this on the PSU Linux machines. Okay, I don't need to see myself. There we go. And so actually let me note that. So I grade your projects on the PSU Linux machines. Therefore, you need to demonstrate that your projects work on the PSU Linux machines before you submit them, and you submit them using a process that only works on the PSU Linux machines. And so then, however, all of your development can be done on whatever machine you want. So, like, I develop here on my local laptop, and then what I do is I commit and push that code up to GitHub, and then I pull it down on the PSU Linux machine and work with it there. So we'll see examples of how to do that here, but there are some setup steps that must occur on the PSU Linux machines. So I have already set up my environment so that I can work with GitHub on the PSU Linux machines. I have some instructions here about using SSH keys or personal authentication tokens. I don't know if PSU has the GitHub command line. No, it doesn't. Okay, so that's another thing that well, you can use it on different machines, but not there. So anyway, so I can do a git clone. So no, I don't have an example of how to do that. Sorry. Okay. So what I want to do is I want to make what's called a git clone of this repository, which is basically like a local copy of it on the PSU machines. So I use the SSH protocol because I have the keys all set up and everything like that. I'm going to copy the URL to the clipboard. And then here on my, I need to log into the PSU machine. So I SSH to me at the Linux machines, which I hope everybody has accounts on the cats on the MKEX Linux machines. You'll need one otherwise. I like to put all my Git checkouts in a directory called Git. And then I will do a git clone, which makes a local copy of the Git URL that I put on my clipboard. And then this will make a local copy. There. It makes a local copy of it. And so now I have a Portland State Java Winter 2024 directory. And there it is, like all the stuff that's here in my GitHub repository has now been copied to the local machine. Pause for a question. Is this the kind of stuff that you've done with Git? Is this what they teach you about Git? Some people, okay, good, looking familiar to most people, and some others not. That's fine. Check out the lecture that I have, and I hope that the intent is that it explains. Let me know that it doesn't, because it's new content and really hasn't been embedded very well. But the whole idea here is that I've got the source code that lives in this accessible place on the web in GitHub that I can all get to, that I can then make a local copy of and work locally. So, okay, I'm going to go into that directory, and it's got all of that stuff. So, okay. This is a course in Java. And so then you need to make sure that the Java development tools, the Java development kit, is available. And so you should have, or rather you need to configure your environment so you've got a command called Java that is on the path. And you need to be running at least Java 11. I'm running Java 16 on this machine. That's great. That'll work. I have some instructions here about how to configure configure your account on the Portland State Linux machines, and then I also have some information about how to get the Java development environment on your own development box. It's a lot easier than it used to be, but there's still some steps that need to follow. So once you have Java all working, now you use some stuff for the course. So one of the things about the Getting Started repository and now the your own local copy or your own repository that you've created from that template is that it comes with a bunch of helper scripts and stuff to get you started. And the first one is called Survey. This is the thing I mentioned in the syllabus. So the whole idea is that you run a survey. It actually runs a Java program, so it validates that yes, you can run Java, and it'll ask you some questions about yourself, like who are you, and your email address, and all that kind of stuff, some demographic information, and then it creates a file called me.xml, which has all of that information, and then that me.xml is used by other scripts to create your projects and things like that. This is something I developed just to make it easier to get started with the course, and you don't have to do so much stuff with Maven and everything like that. It also emails that XML file to the grader, and I use that same XML file to populate my grade book. So again, I know who you are, I know what your ID is, and then actually I've got all this integration with like the grading scripts and stuff like that, so it makes it faster for me. So I can focus on doing important things like assessing your work and giving you feedback, and not so much on important things like bookkeeping and recording the grades and everything like that. So it all starts with the survey.sh. So I'm going to run survey.sh. Survey.sh. Okay, and a little command line program is asked for some information. So my first name is David. My last name is Whitlock. I can leave it blank or say Dave. My login ID is for the MKX Unix machines is Whitlock. My email address is whatever. This is the email address to which you'd like me to send your grades. It could be anything. I don't really care. And then I'm just curious what your major is. Computer science. I'll say I'm an undergraduate, and I hope to learn a lot in CS410J. And there's nothing else I'd like to know. But hey, if there are things you want me to know, this is a good way to do it. I'm just kind of curious about you and what you're interested in the course. And then it prompts me to say that all this is correct. If it is, then yes, and it'll email information to the grader. And also there's an important next step. Now it's created this file called me.xml, and you can look at it. It's a little XML file, and it has all the information that you entered there. In the on the command line, and this file should be added to your GitHub repository, and so then this allows you to. Then this allows. Well, you'll see how it's used later. So, and the way you do that, and so if you're familiar with the git status command, that shows you all the changes that have been made to your repository. It's saying, hey, there's a new file here, and you haven't put it under version control. So I'll do that with the commands that are over here on the left. So I'll say git add me.xml, and then I'll commit it with added some information about me, whatever you want to put there. Great, and then I'll push it up to GitHub. Actually, I'm gonna just give me a moment here. I'm gonna add my key by running SSH agent, and then I'll add my key. So I only need to type in my password once, passphrase once. Nice. Now I can do the git push without it prompting me for that password information. And so just a reminder, if you're not familiar with Git, what we just did was we created a new file on the file system. We added it to the Git repository. We committed it to the Git repository that's local, and then we pushed that change from the PSU machine up to GitHub. And now, so there's not a me.xml file. Now when I refresh, the latest change to this repository is add some information about me, and now I have a me.xml file. Right, so that's what GitHub does. It hosts your repository and lets you see what's in it, moving stuff in between. By the way, is anybody following along? Yeah.
You know if I'm going to find out what themselves.
You have to go to the CAT, I think. So, you know, the computer action team. And yeah, and if you haven't used, do you know if you used to have one or if you have one for other courses?
I'm going to log into the
Oh, okay, that's it. So then you use a user ID for that. Yeah. Yes, sorry, yeah. So if you just do, who am I? Yeah, that'll work too. Yep, cool. Yep. So sorry, and is anybody trying to keep up with all my fast typing and trying? I'm just curious, anybody's encountering any problems? Maybe anybody on Zoom? Nope. Okay. Yes. Well, that was before. Oops, I do not want to end the meeting. I hope I'm not muted. Nope, I'm off. Thank you, though. Yeah. Okay. Great. So I've added the me.xml. Demonstrated that I can run the survey script. This is cool. Okay. Now that I've added the me.xml, I can start creating the projects that we need for the course. And this goes through creating the student project. I'll save that for later. Instead, I think I want to talk about project 1. Yeah, I want to talk about project 1 instead. Okay, so I'm going to go back and forth between like the getting started repository and all the instructions here, and then some other stuff for the class. Oops, one. There we go. Okay, project 1. So, in the course, like I said, we have a 6-phase project that is going to be modeling an appointment book. And so then you've got various appointments in an appointment book. And these are all the classes that you, the Java classes that you'll work with throughout the duration of the course. This is laying the ground here. And the goal of this first assignment is to get you writing some Java code and work with classes that you didn't write. You're going to be taking some of my classes and extending them to add some more behavior. So I provide you with 2 classes called Abstract Appointment and Abstract Appointment Book that model some parts of an appointment. And what you're going to do in this assignment is extend those classes to basically fill them out so they're not abstract anymore, make them concrete, and provide some implementation. And so then in order to make these classes concrete, you need to implement all of the abstract methods that are inherited from that superclass. So here's a little bit more about those classes. So an appointment book has an owner associated with it, and it consists of multiple appointments. And we'll see how all that's modeled in a moment here. And an appointment, so an appointment book is made out of appointments, and an appointment has a description, something like have lunch with Lisa, and it begins at a time and it ends at a given time. Now in this assignment, everything we modeled is a string. In a future assignment, we'll use the date class and things like that. So you can ignore get begin time and get end time for now, and just work with the get begin time string. I think is the name of the method. And just work with the strings. So you have these 2 classes that you'll write that'll model some data, and then there's a class called Project 1 where you work with the data. This has your main method, so this is actually the program that is executed, and there's a command line associated with it. So what it does is it'll parse information from the command line, so you put arguments on the command line. It'll create an appointment book object, add an appointment to it that is described on the command line. The command line has information about that appointment to add. And then there's an option to print out a description of the appointment, which is created by invoking the toString method of that appointment object. And so then this is the command line interface that your program should have. When you run the program, we'll see how to do this in a second. You run it with java-jar. If you run it from the directory that you have the code in, you specify target/appointmentbook-1.0.0.jar. Then you have some options that follow on the command line, and then you have some arguments that follow on the command line. The arguments appear in this order. The first argument is the owner, the second is the description, and then you have the begin and the end time. We'll talk about the format of those shortly. But those may be preceded by some options, and there are two options. There's -print, which will print the description of the newly added appointment, and there's something called -readme, which will print a README for this project. We're not going to go into details about that tonight. Next week we'll talk about it. There is a handout, though. That same documentation handout also talks about what the README is if you want to get a head start on it. The format of the dates and time should be month, day, year, hour, minute. Before I get into some more details of it, let's talk about how we create this project. So now I'm going to go back to the Getting Started repository. One of the scripts here is called Create First Project. And so when you run it, well, it does exactly that. It'll create the skeleton code for your projects, for this first project. And in this class, we use a tool called Maven to build your Java projects. So you've probably learned about makefiles before in the context of C. And so when you're building a C program, you have the compilation phase, and you have the linking phase, and maybe there's other stuff that you're doing and all stuff with the makefiles. Java has similar build phases. Yes, there's a compilation phase, but then you also run tests, and maybe you assemble something like a jar file. And Maven it manages all of that for you. And so we'll see a couple of Maven commands tonight, but we leave the big discussion of it for later in the term once we've had a chance to get a little bit more familiar with the fundamental things. So one of the things that script does is it creates creates a new directory. So if we look at what's been created, there's something called, that file has been modified. That's a file called pom.xml, and pom.xml is essentially the Maven configuration file. It stands for Project Object Model, POM, but it's the configuration file for Maven. And then there was a new directory that was added called Appointment Book. And if we then, do I have LS tree on here? No. If we then look at what's in the Appointment Book directory, now that's pretty big. As you see, it's got a whole bunch of stuff. We'll see a better way of doing this shortly. It has a whole bunch of files there. And so what I want to do is I want to add those files in the appointment book directory to Git, because that's going to be my source code. I want that under version control. And now it adds everything recursively, and so we've got a whole bunch of stuff there that we've added, a bunch of Java files, and we'll be looking at these shortly, including things like your appointment book.java that you need to write, and then also your project1.java. There are things that are for later projects like text parser. We're going to ignore those for tonight. There's also some tests in there, which again we'll talk about shortly. So I add all of those. I also want to add my pom.xml changes to GitHub. So this notice that the pom.xml was modified, and so it's saying now I want to commit that, or I want to add that to the next commit. So I say git.add. And so now I'm going to commit the changes that are currently staged. And I'm going to say added files for project 1. All of those get committed to GitHub, and so now if I say, get committed to Git, so now if I do a git status, there are no changes because everything has been committed, but it does say, aha, your branch, so your current checkout is ahead of origin, which refers to GitHub, by 1 commit, because I have 1 commit that I've made here locally, and I haven't pushed it, so it's telling me I should do a git push, and I will. So that pushes it up to GitHub. So now if we go to the GitHub repository, and refresh, we'll see that the latest changes are added files for project 1, and I've got my appointment book. Okay, that's nice. My code right now lives on the PSU machine, and I don't want to use VI on the PSU machine to edit my code. I want to use something more modern and more rich. And that's where IntelliJ comes in. And so IntelliJ is an integrated development environment, an IDE, that lets you do awesome stuff with Java really easily. But that runs on my local machine. So now I need to get my source code from GitHub onto my local machine. So I'm going to open up another, oops, not another browser tab. I want another terminal window. Here on my local machine, and I'm going to make a checkout of my GitHub repository. I'll keep it on the left, which maybe will make it a little more straightforward. No, sorry, PSU Git. I'm going to make a checkout of my GitHub repository right here on my local machine. Great, I've got all my same code, including, oops, I've got all of the code that I've ever written. I've got, oops, here's all the code from my GitHub repository, including the me.xml that I added and the appointment book code. So I want to edit some of this code. I want to look at it, so I'm going to use IntelliJ. So I will open up IntelliJ. And this is software that you can install. There's also a student license for, well, not just IntelliJ IDEA, but also all the JetBrains products. Really great stuff. And I've already, well, I already have my code checkout. By the way, I could check out my code through IntelliJ. I just prefer to do it on the command line because I'm an old school like that, but you can use IntelliJ. It works great. And now I want to open that code. Oh, there it is. And it is here in my, my PSU Git directory. Here's my Java Winter 2024. Again, this is on my local machine. I'm going to open that up in IntelliJ. And IntelliJ will analyze my files and build its own project for working with it. It'll take a moment here. But it's going and it's looking at the projects, it's looking at the files, and it's putting all the information together. And so now you can work with this code inside IntelliJ. I find this to be a lot easier than working on the command line. And plus, as we'll see, you'll be able to run your unit tests and write your code, and it'll give you good feedback on it and stuff like that. Okay. So let's see what's created here when you create the project. So we saw the appointment book directory, but it was kind of hard to understand all the files there on the command line. I think it's easier to see things in IntelliJ. So it created your project 1 class, which contains the main method. Oops. And right now, out of the box, it comes with some code that creates a new appointment, but just prints missing command line arguments and the arguments passed into the command line. This is just getting started. It'll delete this code and then write the real code that needs to be written, but it gives you some examples. And so I think the next thing I want to do is I want to actually run this code and show you how to run it. So I'm going to go back to the command line. Over here, I'm on my local machine. And so I'm going to go to the appointment book directory where all my code lives. And I'm going to run this Maven W command. This is what's called the Maven wrapper, which will run Maven. And so this is the thing that builds my project. And there are a number of build phases in the project, but the one that I want to use is verify, which is kind of like the end-to-end running of all phases of the project. So I'm going to do that. And what that does is it will compile all the source code. It will run the unit tests on the source code, tell you what passed and what failed. If all that is successful, then it'll go on and build that that jar, that archive that has all of your source code in it that you can run your main method with. And then it also runs something called integration tests, which we'll talk about later. So I ran it, everything was successful. That's good. And if you were watching things go by, you saw things like here at the beginning, sorry, there we go. Here at the beginning, it ran the compile phase, and the compile plugin. It ran the tests, and here were all the unit tests that it ran. Everything was successful, and then it went on and just did a whole bunch of other stuff. But what it created, so that gives you good feedback. It said, aha, look, all of your code compile, all of your tests pass, wonderful stuff. And then it created a file in the target directory. The target creates all the built artifacts, all the things that were built. And then it has an appointment book 1.1.0.0 called jar, .jar. And this is something that contains all of your compiled source code. This is the closest thing there is in Java to like an executable, right? It's one file that contains everything. And so then it exists. And now when you run the command java-jar with that jar file, it runs the main program, which is missing command line arguments. This is the same code that was here in your main method, right? It prints missing command line arguments. And if I give it some command line arguments after that, I say 1, 2, 3, it prints missing command line arguments and each one of the arguments on the command line. So what this does is it executes the main method and passes in the arguments that are provided on the command line. This is the fundamental interaction between the user and your first couple of programs. They're all going to be command line programs, and so then this is the main. This is how you get started. For those of you who have done Java before, is this sounding familiar? At least the main method part. Maven's probably new, but the main method, okay. IntelliJ, is this new? Has anybody used an IDE before? Yeah, okay. In school or professionally or like sort of in between? Okay, good. You've seen it before. Well, you'll be able to watch what I just did now. And then there are more detailed written directions in the README for getting started. So yeah, right, because there are links off like here's where to get IntelliJ and here's how to configure things. I know I'm going really fast. That's on purpose. I don't want to show you everything because some of it takes a little while to install and stuff like that. But that's a big part of what you'll need to do for this first week is just getting your environment set up. So like making sure you have your GitHub repository squared away, that you can create the projects, that you have IntelliJ and Java all installed and working. Yeah. I guess the example I go through here is with the student project, but it's very similar. So this is the source code. You can look at the appointment class also. So this is I basically give you the template. I get you started with things, but your appointment extends my abstract appointment. And so I can navigate into that. And this is a class that I wrote. And now this is a class you can't edit. You don't actually have the source code. You can't edit the source code as part of this. You can view it though. And you can find out everything that you need to know. Again, these git begin time and end time you can ignore for this project. You'll be using it in project 3. If you are familiar with zone date time and you want to use it now, you can. But you don't have to. But anyway, this is how you get started with the projects. You use that create project script to create the source code. You use IntelliJ to use IntelliJ to view the source code. And you use Maven to build it. Actually, for you all, it'll be important to do the Maven step before you open up an IntelliJ, because when you run Maven for the first time, it'll download a whole bunch of these. It'll download all of my code, and IntelliJ will need that. I guess when I run it on my machines, I already got my code. That's why I developed it. So sorry, that's an important note. Before you open things up in IntelliJ, you should run that Maven verify first. And that's probably called out in the instructions from the for getting started. Oh yeah, here it is. Yep, run Maven verify before you open the project in IntelliJ. And you'll need to do things like configure the JDK. Please let me know what you find. As a matter of fact, a lot of these things these notes in here are informed by feedback that I got from students. The reality is that I'm using my development environment, which has been customized for me over the years. That new initial experience is different. And I've tried to capture all the caveats and be sure to do this, and here's how to start over if something breaks. But there's always new things to learn here. Okay, it's 8:15. I think it's time for a break. It's been another hour. So let's take, let's take 15. I think we need a little bit of time. So I'll see you back again at 8 o'clock. Okay, and we're back. How's my position doing here? Oops. I'm off mute, aren't I? Yeah. Space motion. There you go. Good. Terrible lighting. Okay. So, for the beginning of class, we got an overview of what we're doing here. We spent that second part of class talking about the syllabus, and then we started talking about the code and how to get the code. We saw the getting started repository. This is going to be very important for you here in this first week. You're getting off the ground with the course. This is basically what you do to get started. It gives you these scripts that are used to create the projects. And we saw how the projects can be, once the project is created, you can make a copy of, you can make a local clone of your GitHub repository on your development machine, and then use IntelliJ to navigate, to edit the code, things like that. We saw how Maven is used to build the project. And recall here, I've got two terminals. This one on the left here is my local machine. This one on my right is the CS department's machine. I ran Maven verify over here. I can do the same on this repository too. I can say Maven w verify. And because the code is the same, it will, it ought to run the same way, even though they're in different environments. Now, when you run Maven, actually, one of the things you're going to see the first time you run it is that it downloads a tremendous amount of code, which is awesome, right? It downloads all these jar files, all these things that are needed to run the unit tests, to build the code. This also generates reports and things like that, which we'll talk about later. And it's great that it takes care of all of it for you. These tools like Maven are a really important part of having large projects that are scalable, to have many people contribute to them. So we've got all of this. So this is your project one. And let's go back to the assignment now. So again, the way you run your project one main method is by saying java-jar, and then you give the jar file, and it provides all of that stuff. Just a couple of notes here that if you have a multi-word argument, like a owner that has a first and a last name, they need to have it in double quotes on the command line. So again, here, if we run our jar command and we give it, like multiple words, all in one command line argument, that's how you get something with a space, and you need to put double quotes around it. And yeah, again, dates and times, however, should not be quoted. They are two separate command line arguments. So yeah, begin and end, each one of these is two arguments. The first one being the date, and the second one being the time. Lots of footnotes here, including things that we will learn about next week, like the README and the POA, the plan of attack. However, if you want to look ahead into that document in your code handout, feel free to do so. Now, admittedly, this first project is pretty straightforward, right? You're reading from the command line, you are creating objects, and you're maybe printing something out and then exiting. To be clear, you're not writing anything to a file yet. You are creating a brand new appointment book every time. Don't worry, project 2, you start writing to a file. But in project 1, really what this is all about is, yeah, you're writing code to parse the command line, but what you're really doing is learning how to write in Java, learning how to use the tools and build the projects, all sorts of stuff like that. So what the program, but a lot of what the program does is validate the command line. So a big part of what your program needs to do and convey effectively is what is error conditions and things that are unexpected. So your program should exit gracefully with a user-friendly error message with conditions like command line is incomplete, something is missing from it, or there's extra stuff on the command line, or the format of the day or time is incorrect, or maybe the description is empty, right? Situations like that. We might see a little bit of it tonight, but definitely starting next time, we'll talk about how to test your code and the importance of really understanding what your code does under various circumstances, and then providing enough coverage for with your tests to make sure that you're confident, or to give you confidence that yes, your code is doing what you expect it to. Let's see here. Oh, and here's some. I'm not going to go through all of this again, but this is a description of the stuff that you get with your when you create the project. It talks about the unit tests that are added. There's other things in here too that aren't. Sorry, there are other things in IntelliJ that aren't necessarily immediately relevant. These just calls it the stuff for project 1. But you get unit tests and integration tests. And again, as we already saw, you run Maven Verify to build the project. We'll talk about Maven's site later. You can try it; it's neat, but we'll do it later. And then you run the project with Java-jar. This project is due in 2 weeks. Please start it soon. You want to make sure that you can get off the ground, that you've got your environment all set up. So definitely within the next week, make sure that you can get to the point where you, without making any code changes, that Maven Verify passes. That will require you to install Git and install the Java, the JDK, and then also use IntelliJ. That's sort of the bare minimum. I recommend that you start thinking ahead. This is worth 6 out of the 60 project points. Now, there was a lot, but any questions about this first project? Yeah. Very good question. So I know I need to install Linux and IntelliJ on my own development box. Do I need to do that on the Linux machines? No, you don't need to install them. Actually, you probably don't have permissions to install them. But they are there in the environment, and I have some descriptions here with add package. Yeah, here here's like, how do I configure the JDK on the PSU machines? Here's some description of doing that, and I think everybody has Git. Oops, dash for Git. I think everybody has Git on their command line. Yeah, it's in /bin, so you probably got it on your path, so that should be okay. If you're encountering problems, post about it on the Slack channel. You can DM me, of course, but you'll probably get a faster response both from your peers and from me if it's in the classes channel. Yeah. I plan to go on that next week. So that's, but basically, a long story short, you can read all about it here in the How to Document Your Code, How to Document Your Projects. But the whole idea is that 3 days before the project's due, so that's like not this coming Sunday, but the Sunday after that. I want you to write a couple paragraphs about like what your project's, how you're going to do your project. And what this is not only an opportunity for you to describe what you do in words and learn how to do that effectively, but also force you to start your project before the last minute. Method to my madness. Mostly madness, though. Cool. Okay, that's the first project. There's another project that it goes over a couple of weeks, but I'm going to start tonight, and this is called the Java Koans. So, a lot of you, even those of you who have seen a little bit of Java, it's probably been a while, and you probably didn't go terribly deep, or you've probably forgotten stuff. And for some of you, Java might be completely new, and but use Java in this course, and being able to quickly become conversant in a programming language is a great skill to have, right? You start a new job, or your technology department decides to go in a different direction, it's good to know how to pick up a language quickly. And I've found that these Koans are really, really good at it. They're basically a series of little programming exercises, like 3 lines, right? Tiny little programming exercises that teach you about a specific aspect of the Java programming language. Like, okay, here's how to work with numbers, or hey, here's how to use the string class, and here's how to work with inheritance. I've really found that it's very effective and efficient. And I didn't write these. This comes from a dude named Matt Bentley, who I think might be in Chicago or something. And so then, I've with his permission, I borrowed his stuff and I use it here. And so also you can start with this project by using a script in the Getting Started repository. So once again, we're going to go back to the Getting Started repository. This might be able to work on a Mac. I only have a shell script, so I think probably the best thing to do is create the project on the PSU machines. I know it works there. I've tested the scripts there, and then use GitHub to get the code over to your machine. So you say create Koans, project. And now this lays down some new files in a Koans directory. So I'm going to add that to GitHub. I'm also going to add my modified pom.xml. And yep, whole bunch of things. And let's see what these are all about here. I'm going to commit them over here. Okay, Koans project. Oh, and you know what? Did I post the URL to my GitHub project? I might not have, and so I will do that. Oh, looks like, nope, someone else. Okay, cool. Here is the code that I'm showing off in class. You'll create similar code repository for your code, for your code. Of course, your code will be in a private repository in bold. Yes. Okay. So that's where all of this code goes. And so, as you can see, once again, because I pushed to GitHub, now the Koans project is there. And now what I can do over here is, on my, I could do a git pull over, actually, yeah, I'll do that. So I'll do a git pull over here. We haven't seen git pull yet. So what git pull does, I've already got a checkout here, and now I want to get those latest changes from GitHub. And so I can do a git pull, and it now added all of the Koans files that I put into GitHub over here on PSU now are here on my local machine. And so I'm going to go to my IntelliJ, and when okay, it's not going to update automatically, I guess, and that's fine. So I can say reload all from disk. And what this will do is it then scans the disk and notices that there is a Koans directory. It is now analyzing that Koans directory. It detects there's a Maven project there because it turned bold. And now I can navigate that. I can look at all the source code. And so then I've got all the source code. And let's take a look at this stuff by running the Koans. So, and actually, we'll I think it starts with about Koans. Yeah. So there's a bunch of little Java classes here. And they have these methods in here that are annotated with this @Koan symbol. And these are the things that are meant to teach you something about the Java programming language. And to get started, though, there's this main program that you run that will evaluate each one of your Koans. So you go back to the Koans directory, and what does it say in the assignment? It says to create Koans, then you see to that, and then you run this command here, maven w exec :java. This runs a little Java program, that will basically evaluate your Koans and walk you through the process. So it's lots of text here, but it tells you the first thing. It says, okay, great. You need to open this about Koans.java file, which I did in IntelliJ. I opened up about Koans, and so I navigate to it here. You could also have done navigate to a class, so Command O and said about Koans. We get you here. And let's see here, there should be a method starting with @Koan called find about Koans file. Look within it for your first lesson. So you've solved that, save the file, and check back in for your next lesson. And it's saying, ponder what's going wrong in the about Koan class's find about Koans file method. Line 11 may offer a clue as to how you may progress. Now make haste. And it sort of prompts you for these things. It's trying to be like, you know, the wise sage giving you advice. Okay, so it's saying line 11. So there's something wrong on line 11. What does it look like it's wrong? Exactly. It's calling this fail method and saying, hey, listen, if you want to get beyond this, this Koan is currently failing, delete this line to go forward. Okay, great. So I will. And now I go back to my program over here. When I navigate away from IntelliJ, it automatically saves the file. This program here detects the file has been changed, recompiles things, and now it's telling you something else. It's telling you that, okay, great. A Koan is considered complete when it no longer throws an exception. Often there is more than one way to solve a Koan, but only one correct way. This is often hinted at within the Koan itself or the comments appearing here. And so now it's like, okay, great. Now definition of Koan completion is incorrect. Line 17 may offer a clue. Okay. Oh, and by the way, it's told you you've done 1 of 269. Yeah, there are a lot of them, but each one's pretty quick. But they have it. Okay. So here we are. I think it was line 17. Oh, here we go again. It's calling fail. But look at that code, and how do you think we could make this pass? No, set the Boolean to true. Okay. Koan is complete. Yes, your Koan is complete. And oh, look, IntelliJ is telling me type TR. Maybe you meant true. It did. So I'm going to hit return to accept that. Now I'm going to go back here again. Hey, more stuff. Okay. I'm going to get back to this later, but I've now made some changes. And one of the things that I like to do is commit early and often, right? I've got my code to a good place, and now I'm going to commit. Now, we saw using the git command line to add files to git and then commit them and then push them up. We can also do that through IntelliJ. And for me, I just want to stay in one environment and go quickly. And so I like using IntelliJ to commit my changes. So over here on the left, you can navigate to a commit tab, and it's telling you that there has been one file that's modified. When the file's name is in blue, it means it's modified. And so I can select that change to one file has been modified. To commit it, I enter my commit message here. I'll say completed the first Koan. I will click, I can just commit it here to the local repository. I can do a commit and push. I'll do a commit and push. It's telling me there's some warnings, probably some code warnings. I have a plugin that will tell me about code warnings. But don't worry about it here. And now we can push it off to GitHub. And I'm just going to go back to the PSU machine, and actually I'll go to Koans, and I'm going to run that Maven W. Oops, I'm going to run that Maven W exec Java again. Oops, Maven W. And I haven't gotten my changes yet, so this should be failing for the first one, and that's yes about Koans. Okay, that's good. So I'm going to quit out of this one by entering Q. Now I'm going to do a git pull to get those latest changes. It told me that, okay, look, there was one file that was changed. It was about Koans. That's the one I changed. Good. Now I'm going to run Maven again. Okay, and it's going faster. Oh, wow, looks like it printed out stuff twice, which is interesting. Nice. This is how I move code back and forth between the two machines. Some people noticed, well, said, hey, doesn't IntelliJ have the ability to SSH from a machine and operate the code remotely? Yes, it does. And you can use that, and that's a fine feature if that works for you. One of the things that I'm going to demonstrate, though, a lot in this course to reinforce it with you all is how you use GitHub to move, to have very well-controlled movement of code from one machine to another, so that you know that you've got all your changes there, which is much safer than just like SCPing things around or whatever. Nice. Okay. So meanwhile, back on my machine, let's explore this Koan a little bit more. Let's explore the next one. Okay, the underbar are an attempt to communicate the need to fill in an answer. Judging by context, what should underbar be replaced with? Okay, ponder what's going around in about assertion classes assert boolean true method. Look for line 13. It said expected true, but was replace me. Okay, so about assertions. So I'm going to go back to IntelliJ, and I'm going to open up and navigate to the class. I'm going to say about assertions. Oops. About assertions. Okay. Here we go. I'm in the about assertions class, and here on line 13. Okay. Assert Boolean true. So there are two possibilities, true or false. What would it be here? So if we're asserting that this value underbar, which if I hover over it, oh yeah, it says, well, does it tell me what the value is? No, but it's underbar. Okay. We should replace underbar with something. What should that something be? Oops. Okay, let's go find out. Great, we're now at 3. Okay, so we got that one working. Next one, assert Boolean false. Well, what do you think? Assert false. False, yeah. Okay. These ones at the beginning are kind of brain dead, and that's okay. They get harder, don't worry. It's cool. Let's just see that one. But you see what you're doing here? You're taking these little bites, these little steps. And I know it might sort of seem like, hey, listen, I already know this is obvious. And that's okay, right? This is very much a slow and steady wins the race. You'll see by getting these little pieces together, you'll be much more familiar or much more comfortable approaching the big pieces of code later. Okay. A keyword in Java to represent an uninitialized reference is null. There are times when something should be null, as assertion can prove that. Okay, let's look for assert null object. And it says expected null, but was replacement. Okay, so here we are now. It's line 25. So assert null, what should we put in here? Null, yeah. Okay, once more. We're at 4. How are we at? Now we're at 5. Great. Okay, wonder what's going wrong in assert null object reference. Line 31 may offer a clue, expected null, but was replacement. Okay, so let's look at line 31 here. We are asserting that some object has a value of null. What should we put in here? Okay. Right, and this is demonstrating to you that you can assign a null to an object variable, right? Now, it's interesting that IntelliJ underlined this in gray. What does it say? Value some objects are always null. You're right. This is not like great programming right here, but that's okay. The Koans are meant to be these little bite-sized things that teach you things. Okay, great, we're at 6. Now we're at line 37. Let's see here. Sometimes you merely wish to assert an object is not null. This assertion should be used sparingly. Often a more specific assertion is appropriate. And something other than null but was null. Okay, on line 37. Okay, so what should we put here on line 37 instead of null? True, okay, let's see here. True, does that work? Well, it compiles, right? So let's see if it runs. Well, it did, and that's interesting, right? So true is a primitive type, and if you either recall or if you go back and watch the Java review lectures, I talk about primitive types versus object types And I also talk about the auto boxing and wrappers and things like that. So you can do this in Java. You can say, even though this method, so let's see here, if you look at parameter info, it takes an object. You can send in a primitive type to this, and it works. Okay, cool. Okay, assert equals using expression. So I'm saying that I want to assert that the string hello world equals what other string? Yeah, hello world. Make sure I got all that. Okay, and even look at IntelliJ as warning you're doing something kind of dumb. It's like, you're calling it on itself. And be sure this is what you want to do. In this case, the answer is yes. Okay, line 47. Oh, look at this one. This one's a little bit more interesting. So this is teaching you how to use these assert equals methods because you'll be seeing these throughout the rest of the cones. Okay. Okay. Just call it out. What should these be? This first one, assert equals. Yep, hello world. Again, this isn't teaching so much about Java as it is what these assertions are all about. Assert that 1 equals. Yep, there you go. 2 plus 2 equals. Yep. 2 times 3 equals. Yeah. Everybody sing along. 3 minus 8 equals minus 5. And 10 divided by 2 is? That's positive 5. Let's see how we do. I see there's a question in the chat. Do you recommend we do these one by one? You know, yeah, you are seeing me go back and forth a lot between like IntelliJ and the command line. These ones at the beginning that are, let's face it, obvious, right? You can breeze through these, right? It's the I think you will know, or rather, pay attention to when things are a little more tough, or like I just did 8 of them and I got the first one wrong. Oops, right. So I don't know. I guess I don't have really good advice on where to start, but you can try doing them one by one, see how that works. You can try doing a larger batch, but as with any larger batch of work, if if there's something that you didn't learn at the beginning, you can that can then impact stuff later on. So sorry, I guess I don't have any hard and fast rules for that. Nice. Well, anyway, I think you're sort of getting the gist of all of this. Why is that line red? Is it going away or something? It's weird. Oh, it's deprecated. Okay, it's good to know. Anyway, so the whole idea is that you've got this series of tiny little systems of Java code. And the intent is that they're small to sort of fit in your head, and you can look at them and then reason about what all these assertions are. If we go back to the code, we'll see that there's all sorts of things that we learn about. Here in the beginner stuff, we learn about arrays and doing arithmetic and working with strings and loops. Right? I found this is a really great way of learning like all the pieces parts of the language. Sure, you can read a book. Sure, you can watch my lectures, right? But there's something about actually tactilely getting in there and writing a little bit of code that I think really reinforces these lessons. So I'm going to commit these, and while I'm doing that, any questions about what the Koans are all about or how you work with them? Yeah. Yes. One repository. Yes. Thank you, Kate. Yeah. For this class, you only need to create one repository for all the code that you're going to write. Right. Yeah. So so just make a copy of the Getting Started repository once, make it private. All your code will be in there. So you'll create project 1 in the Koans tonight. A couple weeks, we'll create one for project 5. And then we'll see how to add stuff for the Android project in there. That's all going to be in one project. That keeps it simpler for you. And we'll see some some about continuous integration later on too. Yep, good question. Okay, so commit and push those up. Okay. So, you know, as we saw, there are like 269 of these. There's a lot. They go, you know, some of them go pretty quickly, some of them don't. But they're due in whatever that is, 4 weeks, because there's a lot of them. That being said, I recommend that you know, do a bunch each week, maybe every day, or like, hey, listen, you know, skip the weekends or on the weekends or whatever. But because they're really, they give you the coding tools that you'll need to do project 1 and project 2, which is assigned next week, right? So you know, it's a bunch of stuff to balance at the same time. But I recommend that you not save these to the end, not only because it's a bunch of work, but you won't get the right lesson out of them. So really meant to, you know, learn how to use the language through the Koans and then apply it in your projects and in your in the coding that we do here together. Okay. Any further questions about that? Okay. Which video? Let's talk about test-driven development. Okay. What do I want to do? I want to show you some tests. Yeah, I'm going to show you some tests first. So we saw the Koans, right? And the Koans, they have this thing where they do this assertion, right? And an assertion is whether it is an assertion in the Koan, whether it is an assert statement in the Java language, or whether or not you're, as we'll see, making an assertion in a unit test. You're basically making a statement about something you believe to be true. And this is incredibly important when you develop software, because you have all of these thoughts in your head. You have all of these assumptions in your head, like, okay, well, I just did this, so therefore this variable must have this value. Or, oh, I did that a little while ago, and so I assume it's still true. Or I assume that my code behaves the way that I expect it. So, like in the appointment book class, that when you set the or when you add an appointment to an appointment book, that yes, that appointment book contains that appointment. So you can make an assumption about that, but what you really want to do is validate it. You want to be able to say that, yes, my code works the way that I expect it to. And that's what an automated test is all about. It is code that tests other code, and it makes these, and it checks properties of the code, checks attributes and behavior of that code with assertions. There is, and so what you do, so I'm going to go back to the appointment book now, and we looked at the main method for project 1, and actually let's also look at, I want to look at the test first because I don't know exactly what we test here. So if you look at in Maven, you lay out your source code in a number of directories. And one of the things that you do is you keep your source code, this is the code of your main application, separate from your test code. There's also something called integration tests, and we'll see that next time. But the whole idea is that your test code is separate from your main code because you ship your main code to your customers, you deploy your main code to the production environment, but you don't ship your tests. The tests are just for development and for validating the code before it ultimately goes to its end destination. And so I have here, I have an appointment class. And so appointment extends abstract appointment, and right now it doesn't really do all that much. As a matter of fact, all of its methods are to be implemented. So like the begin time string method, which is something that you need to implement to set the time string that you send in, throws an unsupported operation exception saying, hey, listen, I'm not implemented yet because it's your job to implement, right? Out of the box, I give you like the skeleton and then you need to implement it. Same thing with the get description. It just says this method is not implemented yet. And so it's got some behavior right now. And to demonstrate that behavior, and to validate that behavior, I have an appointment test class. So this is what a unit test looks like. Unit tests use the JUnit API and also something called Hamcrest. There's one of the lectures that I'd like you to watch this week that explains all of this stuff to express and validate these expectations that we have of our code. So, and the neat thing about these tests is that it's just Java code. It's more Java code, but it's Java code that tests other Java code. So here's the first unit test. And by the way, this is not something that you're going to keep because you're going to change the behavior. So get begin time string needs to be implemented. So what does it do? Well, it creates a new appointment object. And recall, and I'm going to split screen this so that we can see them next to each other. Hope that's big enough and visible for everybody. Over here, we test the fact that when we create a new appointment object and call its getBeginTimeString method, that it throws an unsupported operation exception, which is exactly what it does. So when I run this test, which I can do through IntelliJ, IntelliJ will go through and build everything and then run the test. It passes. Well, current so you can see it. So it ran the getBeginTimeString needs to be implemented test inside appointment test, and it passes. The other test here, and we'll modify this shortly, is says, hey, listen, initially all appointments have the same description. And so then it's going to, I'm trying to fill on one screen. So it creates a new appointment and it says, hey, listen, when I call getDescription method, which is this thing over here, on that appointment, it contains the string not implemented. There's not implemented right there. So I'm going to run that, and it passes. So this is the pattern that you follow. You write a test, and then it passes. Now, this is not, clearly this is not the capability that you want. You want the description of the appointment to ultimately contain, to return the description that maybe you pass to its constructor. So I'm going to change this, actually I'm going to delete this, this test, because what it does is it tests like the out-of-the-box behavior, and so this is an example of how to write a test, but it's not really what I want. Instead, I want a test that will validate that, we're going to say the description of an appointment is the description that passed to the constructor. I am famous for very very long method names, but you know what it means, right? You know what we're testing here, right? Okay, so what we're going to do, we're going to make an appointment, and we're going to call it appointment, and that's going to be a new appointment. Oh, and by the way, I'm going to, okay, but now instead of having 0 arguments, I'm going to have a description that I want to pass in. And I do not want that thing, so I am going to, actually, sorry. We'll do all the IntelliJ stuff next week. I'll just write the code. So I'm going to have a description variable. This is going to be my description. And when I create the appointment, I'm going to pass in that description. Now, IntelliJ has an underlined in red because there's a problem, saying, hey, wait a second. Appointment has a 0 argument constructor because I don't declare one over here. You're trying to pass in 1 argument. What's going on there? And so it's telling me I can do some things. I can create the constructor or I can get more actions. I just want to show you what happens when you click more actions. It gives you some things like I can remove the argument. I can do that and it gets rid of it for me. That's kind of nice. Not what I want to do, but that's nice. I'm going to put it back. And now I'm going to say, well, I can create the constructor. And IntelliJ then creates the constructor for me, which is super nice. So, okay, the constructor takes one argument, the type is string, and the name is description. Great. It's telling me I've got some problems. And what are those problems? Let's see here. Related 3 problems. Appointment book. Oh yeah, I still have the 0 argument constructor here. So here's what I'm going to do. I'm going to add a 0 argument constructor there too, just so things compile. And I think that should make everything happy now. Okay, fun. You're thinking about things. Huh, I don't know why it's still saying it's a problem. It should be okay. Because like, yeah, it's not complaining about this appointment constructor. So I think this intelligent needs to go that together. So I create my appointment over here in my test with that description. And now I'm going to say that the following. I'm going to say assert that. So this is a method that's part of the Hamcrest API that makes this assertion. I'm going to assert that when I call appointment.getDescription, that the value that it returns is equal to my description variable that I pass the constructor. This is the behavior that I want, right? I want to be able to specify the behavior of, I will specify the description for my appointment in the constructor, and when I call getDescription, I want that description back. Okay, my test has been written. This is going to, demonstrate what I want to be true. I'm going to run the test. I want to see what happens. It failed. It failed with an assertion error saying that I expected the string my description. So here on the assert throws line, I'm sorry, here on the assert that line, and oh, it's underlined in red, so you know which one failed. And I expected, and the first value here is the expected value. Oops. Yep. Yep. So I expected, oh, sorry, this is the expected value. Description, I expected the string my description, but what I actually got when I called getDescription was this method is not implemented yet. Which is true, right? I haven't changed getDescription to return the description that was passed into the constructor. Okay, I'll make that true. So what I'm going to do is I'm going to put the description, I'm going to take the description parameter here and assign it to a field in the class. I'm going to, sorry, I need to do this the forwards way instead of the do otherwise. I'm going to create a field. It's going to be private. It's going to be a string. It's going to be called description. And I'm going to assign that description field to the description, or the description parameter, the description field right there. And now I'm going to change my implementation of getDescription. Instead of returning like this stock string, I'm going to say this dot description. And so what does this do? Again, hide this with more screen real estate. When I create the appointment and pass in a description, I'm going to take that parameter, set it to the field value, right? It's bold here, so you know it's a field. That field value, and then when I call, and then in my getDescription method, when this thing is invoked, it's going to return the value of that field. And I'm pretty sure it's going to make my test pass. And it does. So what we've done is we wrote a test that expressed our intent, that expressed what we wanted to be true. The first time we ran it, it failed because we hadn't made that reality yet, right? It had a different reality. It was returning that stock, string, that hard-coded string. And so we changed. We changed our implementation to do what we thought was right. We ran the test and validated it, and therefore it's right. And this right here is the essence of test-driven development. You write your test to express your intent, to express your desire of what you want, and then you watch it fail, and you say, great, okay, it's not there yet, and then you go make it green by implementing the code that you will then will create the result that you have codified in your test. To reinforce this, we're going to watch a video by Uncle Bob Martin. Bob Martin is a thought leader in software craftsmanship, all about all about test-driven development. This is an excerpt from a video, but it's a little silly in places. He's got this silly hat, but I think it does a good job of explaining it. Oh, and sorry, in order for people to hear it remotely, I need to share my audio. I think I need to reshare. Sorry, can I do that here? I'll do a new share, and I will share sound. Sure. And I'll optimize for video clip, and I'll share the desktop again. Looks like I'm sharing audio. Okay, let's give it a try. People remotely, if you can't hear it, please speak up. Oh, I apologize for that. Let's see here.
Oh, it's time for the red-green refactor cycle. And I am in the red phase. I must write a failing unit test. All right, what test must I write that will force me to write public class game? Well, I'm going to write can create game. Game G equals new game. Oh, heavens. Thank you, IDE. Helpful IDE. That's enough of that. Heavens to Murgatroyd, that doesn't compile. Well, I must make it compile. So now, I'm going to create the class game. Yes, in the current package, there it is, the class game. And if I go back to my test, oh, look, the test passes. It's time for me to go to the green phase. I am now green. And in the green phase, it's time for me to refactor. Is there anything I can refactor here? No. Nothing to refactor. Very good. Then I am done with this test. I am passing. Lovely. Back to the red phase. The next test, well, I know I want to write that roll method. All right. Test can roll. Oh, heavens, I need a game. Game G equals new game. Lovely. G dot roll. What should I roll? Well, let's roll a 0. That doesn't compile. Okay, time for me to focus on making it work. I'm going to create the method roll. Ha! Look at that, roll. And it should take a pins. This is lovely. And I believe that will pass. Because I'm not actually testing anything. Oh, time for me to refactor. I've got a passing test. What's to refactor? Oh, goodness, I've got duplicate code here. Duplicate code. Well, I better take that and refactor that out. I'll create a field named G. I will initialize it in the setup method, which of course I don't have, but this will create. I'll keep it private. Lovely. So now I've got a nice setup method. It's going to create the game. It'll put it in the private field G. Can create game is now empty because, well, it doesn't do anything. And I think I can get rid of that line of code in can roll. And all of this should still pass. It does. I think I can get rid of that empty test now. This is common, by the way. You write a test just to delete it later. Lovely. Next most interesting test case. Back to red. Well, what can I make fail now? Oh, I got to write the score function. Ooh, but I can't call score until I roll a complete game. Okay, so here we get into some of the technicalities of test-driven development. When you must write real code, you write the simplest real code you can. In this case, I'm going to have to roll a complete game. What is the simplest, most degenerate complete game that I can roll? A gutter game. Let's roll the gutter game. Okay. 4 int I equals 0. I less than how many balls in a gutter game? 20. I plus plus. G dot roll 0. That will roll 20 zeros. That is a gutter game. And now we will assert that the score is 0. Oh heavens, that doesn't compile. I must make it pass. Excellent. I will make this compile. It should return an int. I'll have it return a -1 because I still want to see it fail. It should fail. Yes, and now I will make it pass by returning a 0. This is stupid, but it's also easy. And I have now seen my test both pass and fail. I know my test works. It cost me nothing, but I now know that my test will fail if I don't get a 0. Well, that was nice. What is the next most interesting test case? Or is there any refactoring to do? No. Next most interesting test case.
Happy coding. So that's a little 5-minute video that goes into some more details about test-driven development. What were some of your observations about that? What are the things that you saw? What piqued your interest? What seemed familiar? What seemed unfamiliar? Yeah. Sorry, Amanda? It's a good point. Yeah, the first couple ones just passed right off the bat because there was like no functionality there. I think that's a very astute observation. What you want to do is what he was doing at the end, right? At the end, on the last test that he wrote, it did fail. He had to return the -1 when expected 0, and then he made it pass. For those first 2 tests that he wrote, there was not a practical way to make them fail. Right? All you're doing is creating an object. And so I think he did that just to say, hey, when you first get off the ground, you end up writing like very simple tests just to explore what the implementation looks like, what the names of your classes should be, what their constructors should take, things like that. Then as you get more into it, you start getting more of like the test that I'd show, where there we already had an implementation. What we're doing is augmenting the implementation with some new behavior. We first write a test that validates the expected behavior. We see that the expected behavior hasn't been implemented yet, and so the test fails. And then we go through and then we change the implementation to make the test green, which is what he did in that very last step. But you're right, those first couple of tests we never saw fail. We saw them not compile, which is a form of failing, but it's not the same as like the behavior under test is different from what we want. Yeah. Refactoring, yeah. Yes. So refactoring, right? And when I showed you, what I showed you was just going from red to green, which is like the first 2 phases of test-driven development. Yes, that third is refactoring. Now we'll go into refactoring in detail later in the course. It's an important part of contemporary software development. But for day 1, what you need to understand is that once you've got your code working, you want to look for opportunities to improve your code without changing its functionality. So this is where you look at your variable names. Do they make sense? So like if you go back and look at them a week later, or someone else looks at them, are they good names? Is there duplicate code? A lot of times, to get something to work, you end up, copying some code from someplace else, or you end up, writing the same code over again. And you're like, oh, can I take those 2 copies of the code, put it in one place, and just have those 2, and have the original code refer off to that one place that it exists. And then there are more advanced refactorings about, as your object hierarchy and your class hierarchy matures, and you add subclasses and things like that. Is there code that can be hoisted up in the hierarchy? All sorts of good things like that. But yes, this pattern that you get into is like, I have some behavior I want, and so I write a test that validates that behavior, but it's not implemented yet, and so it fails. It's the red, right? Then the next thing I do is I write code that makes that test pass. And so I implement the code that has the behavior that I want. And then I look for ways to improve the code so that I can go faster in the future, and so that the code is easier to work with. Great. Other observations you would like to share? Okay. Well, good deal. I think that's it for tonight. So next week, what we're going to do is we are going to focus on test-driven development. And I'm going to be demonstrating test-driven development with all of you. It'll be interactive. I'll be asking for test cases. As a matter of fact, what we're going to do is we're going to begin class with brainstorming some test cases for the student project, for Project Zero. In the meantime, though, please get started with your Project 1 in the Koans. So go look at the Getting Started repository here. Sorry, let's go up to the top. Look at the Getting Started repository and go through these steps. Please give me any feedback on things that aren't clear or maybe that don't work anymore. I haven't validated all of these steps in a year. So make sure, please let me know if there's anything that's unclear here. Make sure that you can get to the point where you have Maven Verify running on your Project 1 and that you can do a couple of Koans, right? Make sure that's there. As a matter of fact, it's probably good to make some good headway on the Koans in the first week. Also, if you want to learn some more about Java, I recommend this Java programming language overview. That'll sort of help get you oriented, especially for the Koans in Project 1. If you want to dive into some more GitHub, I recommend the source code management with GitHub slides. And then also be sure to check out these next set of slides for next week. This will get you ready to do Project 2. So Project 2 is all about working with files. And so that's the core language APIs and Java I/O. And then also this unit testing with JUnit screencast. We'll be doing a lot with test-driven development. And you saw me talk about things like JUnit and Hamcrest and those APIs. Those slides go into all the detail that you'll need to really understand what that's all about. I think it'll help you, get what you need out of our time together next week. So that's everything I've got for tonight. Any final questions before we break? If not, thank you very much for joining us tonight. This is a long one. Next week will probably be a little long too. Ending around 9 o'clock. But there's just a lot of good stuff to learn here at the beginning. It'll give you a good solid footing for the rest of the course. Please be sure to join the Slack community. That's where I'll give you a heads up on anything that you need to know. Hope you all have a great, safe, and warm week. I look forward to seeing you next time. Good night, everybody. Thanks for joining online too. Bye now.
Yeah.